Hey y'all, I wanted to do a few Newton problems here and just talk about how I use Excel to do this. Because when you do some of these, um, you might think, oh, we didn't learn how to do this sort of thing in class. And, um, part of this is sort of about problem solving, about thinking about how to put together the things we do know in order to arrive at the solution. And um, the way that Newton provides the instruction on this is always very algebraic, which kind of bothers me because it's not really, from my perspective, a necessary tool. It's a place where a lot of people have math scars. So I try to, think of creative ways to solve problems that don't involve algebra because you don't need algebra to solve all these problems. Which, although, algebra is a perfectly good tool to use if you're comfortable with it. All right. So I'm just going to do a couple questions and put this out there for you if you want to look at it. So this first question asks about simple interest. So that's critical. And I'm going to write down something I know about simple interest, which is that the interest equals the principal times the rate times the time. Then I notice that as I go through and look at the question, here's some information provided: 25 years, 4.75%, $2,375. So I'm going to write down some things. 25 years, 4.75%. By the way I'm going back and forth is Alt Tab on a Windows, and it would be Command Tab on a Mac. It's a very useful tool so that I can quickly switch back and forth between one application and another. And this is interest. And it's money. So just do a quick formatting there. Money. Okay. Although notice that when I do that, I lose a lot of the buttons here. So, all right. Well, normally if I have the principal and the rate and the time, I just multiply them together to make the interest. But here I have the interest, and I know that when I have the rate and the time, but I don't have the principal. And so, one way of thinking about this is what times 4.75% times 25 is equal to 2,375. And this is a place where Excel can help me a lot because I can say something like, well, I know I need to take this number and multiply it by 4.75% and multiply it by 25. Right now, that's equal to 0 because I'm using a cell reference that has nothing in it. And so that Excel interprets that as 0. If I started with $10,000, just as a starting point, this would be 11,000. That's way more than I need. And I noticed 10,000 to 11,000, this number is a little bit bigger than this number. So I'm going to say 2,000 is my next guess. And there I am. Okay, two guesses and I got there. Woohoo! Okay, let's look at another one. Bank account, simple interest, 15% to, whew, what kind of bank account this is? 15%, 2 years. At the end of that time, the account had a value of 4,000. Okay, this is tricky. This is real tricky. I'm glad we did this question. All right, here we go. So I'm going to write again, the simple interest. This is important. I know I got a 15% interest rate. I know I got 2 years as my time frame. I know 4,000 is my total at the end of 2 years. Okay. This number does not fit into this equation. And basically, then the things I can reason about are, well, the value of the investment was less than 4K. That's one thing I know because it grew because of the interest and now it's 4,000. But I don't know the interest and I don't know the principal. And that makes that question even harder because now I kind of know where to start. But again, I'm going to start here. I'm actually going to copy this, paste it, change the numbers just to kind of create a little map for myself. 15% times 2 is equal to, I also don't know, but I could add that number onto the principal. And this is really where algebraic thinking does kind of shine, but we don't need algebraic skills to solve the problem. I want to know what principal times 50% times 2 gives me the interest that when added back to the principal would then give me what I want. And so I'm going to have my guess here, my principal. So I'm going to say, I don't know, 15% is a big percent, but it's only 2 years. So I'm going to say $3,500. And then I'm going to say, what would the interest be in that situation? All right. Well, I would take my 3,500 multiplied by 15% and multiplied by 2. All right. And then I would add these together. And I can already tell I'm way over where I need to be. So this is my total. All right. Well, that was okay, but not what I wanted. I'll do 3,000. And I can do autofill now because I've already done this as a cell reference. And so this is pretty close, 3,100. And let's see. Okay, too much. And 3080. Oh, really close. Now, round to the nearest dollar. Do not round until you calculate your final answer. I'm going to do 3078. Oof. 3076. This is pretty good. 3077. Ooh, which one is the better answer? Now, I'm going to try 3077. This is pretty darn close. Woo! Now, notice that they give you actually a new equation. And we can talk a little bit about this. I don't know. Again, this is not really, from my perspective, an important part of the course. But basically, we're taking the principal, we're adding the interest, which is principal times rate times time. And in algebra, there's a factorization process where I could pull out common factors. The p is common to both this part and this part. And so now I have the p times 1 plus rt. So that's where this equation comes from. We don't really need to know more than the principal times rate times time concept, but it is nice to have this other version, and then we rearrange it, and they rearrange it, and then they just plug in the numbers, and bam, they got your answer. Well, that is pretty sweet. But again, do you have that equation? Do you know what it is? Can you pull it out of your head? So all of that stuff has always made me feel like there's this artificiality to the algebraic approach when we're trying to solve real problems. Because if you're solving a real problem in the world, it's unlikely that you are going to have exactly the equations that you need at hand, and better to develop good problem solving skills. So what I'm modeling here is a little bit of trial and error using Excel to calculate forward based on an unknown value. I'm just guessing, and then calculating interest, putting it back together to see what that ends up as a total. All right, let me look at one more. Simple. Okay, this looks like it might be hard. 2.5%, 20,000, 6 years. What must this principal be? And so we start with the compound interest formula, similar to how we would start with the simple interest formula here. Compound interest formula is principal times 1 plus the rate divided by n raised to the n times t. And what the things that I know, 2.5% is my rate, and it's compound monthly, so 12 is my n because of monthly compounding. And what else do I need? 6 years. and I'm gonna separate my numbers and my words so I can use these numbers if I want. And then I want $20,000. And so this is what I'm aiming for as my final amount, right? So we're trying to invest for 6 years, compounding monthly, 2.5% rate, and end up with $20,000 so that at the end of that time, I can have what I need. There is a better way to do this, which is repeated monthly deposits to get myself to $20,000, but that's coming later. So here we go. I have actually everything I need for the back half of this part, which is not showing up well there. This part, because I've got the R, N, and the T. And so basically, if I figure all of that out, then I have something times that number equals 20,000. And, that little piece of math right there, where I have something like, hey, 20 is some number times 4, is a place where we could apply some algebraic thinking, divide both sides by 4 to figure out what x is. That's inverse operations. But we can also just use this concept of like number sense or opposites in order to figure out that if 20 equals this number times 4, then 20 divided by 4 would be equal to this number. So obviously 20 divided by 4 is 5, and that is the magical number that multiplies by 4 to give me 20. And so that relationship between multiplication and division is important here. So I'm going to go ahead and calculate all of this part here equals 1 plus the rate divided by n raised to the power of n times 6. And I get this crazy number. And then what I'm looking for essentially is 20,000 equals 1.16 times this magical number. And again, so using kind of reverse logic to say, well, if 1.16 times this number is equal to 20,000, then all I need to do is answer the question, what is 20,000 divided by this number? And this is a good answer in several ways. It makes sense for me because it's less, so it's growing to 20,000, which is what I expected it to be. Let's double check to the nearest cent. Okay, so we do need to be really specific here. 17,216.85. The reason they're saying this stuff about don't round until the end is because that number, this number, if I round it in between, is going to give me a different answer. Let me show you what I mean. 1.16 is kind of approximately 1.161652, blah, 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 blah. But if I take my 20,000 and I divide it by this number, I've got a different answer. It's close. It's like $25 off, but it's different. And so this is another reason why I don't want to do the rounding in between. I think Excel makes that easy with the cell references. You just do the calculation for one part and then do it for the other part. In a calculator, if you had done this, you would have to figure out how then to do the 20,000 divided by that number, which some calculators make easy. iPhone calculator, probably not that easy. Although I do think they just made an upgrade. But anyways, I'm going to stop there. I got tricks up the wazoo, and if you're struggling and you want support, first of all, don't struggle in isolation. It's not helpful. It's not productive for you in terms of your feelings about mathematics. So start early, recognize, oh, this is hard. Get in touch with your lab instructor, specialist, your instructor, me. There's lots of people who can help you. So don't feel like I just gotta do this on my own. And if the explanation you're getting is not feeling good, keep in mind there's always more than one way to solve the problem. All right. Be good. Keep working hard.